Okay, thank you. So yes, my name is Raphael. And I'm here to talk about my experience doing continuous delivery at the company I was working on in France, Raphael.com. Raphael.com stands for the ferrets in English. But first, let's briefly introduce myself. So I'm a French software engineer. I worked for the past 6 years in Paris, doing primarily Java and Scala web development. I have a few books that inspired me, few related to software craftsmanship, one for continuous delivery, obviously, and on my last years, 2 years in Paris, I worked with this school. Yes. Raphael.com, mostly on the data team when I was doing migration from MySQL to Cassandra and playing with Spark and so on. And this is why I even hired me to join the US team in DC to work on big data projects. So the company I was working, Raphael.com, it's an insurance comparison website. So primarily they are doing car insurance comparison, home insurance, loan insurance, and so on. And the core business as a website is to transform and convert people landing in the pages to people subscribing in insurance at the end. It's the leading on the French market, and the brand has been launched in 2012, but the company already existed with another name, and more importantly, the code base already existed. So the code base is 7-8 years old now, but it's a pretty good code base for this age. There are now 60 employees, and talking about volume, it's about 2.5 million quotes of insurance per year, which is a pretty good number for the French market. So yeah, the company is 60 people, and about half is dedicated to IT, because at core it's a website. So how it is organized? Well, 20 developers, 7 business analysts and product owners, and everyone is split in 4 what we call feature teams. And by this I mean every team of 6 developers is dedicated to a part of the site. A team is dedicated to the landing page, the SEO, the static pages. A team is dedicated to the funnel, where you fill the form and where you get your quotes at the end. A team is dedicated to the data, all the data of the site and the reports. And a team is dedicated to the insurance collection and calling their APIs in real time, getting the quotes in real time and so on. Plus the teams and the developers, we have 2 admin systems to help deploy the site and so on. And 1 architect, his primary job is to do coding as well with the teams, but he's there to ensure that there is a coherent, consistent architecture on the site. Talking about architecture, so the architecture of the site is very simple. It's a raw WAR application, a few WARs that we deploy on Tomcats, many Tomcats, on many servers for redundancy. It's all on Java, plain Java, without any framework. The front end is GSPs for the static pages and GWT for the funnel. There are 400,000 lines of code, so it's not so big for an application like this. But more importantly, this number didn't increase in the last few years. Because every time we add a feature, we take care of that. Removing features not performing well on the website. And there are 40,000 of unit tests, which is pretty big. And this is because for a long time the company and the IT team had a testing culture. So this is roughly the architecture of the website now. Now,
I have a question. Did you have any testers on the teams? Because you talked about any testers.
No. All the tests were done by the developers. We have a QA at that time, and we still don't have QA. Yeah, I'm talking on present. Yes.
So your client, the folks, they don't have QA either. They just accept right off the bat, or just the team.
The team was doing the QA. We didn't have separated QA. There's another question.
In addition to the unit tests, do you also have component tests or
Selenium tests.
so?
Okay. Yeah. Yeah. So this was the state of the team and the application in 2012. At that time, the methodology was Scrum for the organization. Also, there was only 12 developers. So because we were using Scrum, of course, we were doing iteration. Each iteration was a 3 weeks sprint. And the build, so by build I mean packaging the application, run all the tests, and then deploy it on the testing environment was 15 minutes, which is pretty long when you are a developer and you want to run your test locally. And the Selenium tests when deployed on the testing environment were 1 hour long, which is okay, but not so good when you want to deploy faster your application. The mindset at this time, because of Scrum, I would say, and because of the organization, was more about planning everything up front, estimating your stories when you are doing Scrum, then coding, focus on coding for 2 weeks, 3 weeks. Sometimes a rush at the end of the sprint to complete all the stories you were committed. Then deploy your application at the end of the sprint. Test your application in a testing environment to the UAT and fix the test before finally going in production. So the business at that time, when they wanted a feature, they know for sure that it will take at least 1 month between planning the feature to having it in production, which is pretty long for a website. 1 month planning. Now this is where we ended up on 2004, and this is what we do since 2014. We have now accelerated the build to 3 minutes, which is very nice when you are a developer and you want to build locally and run all stats. Selenium are now only 15 minutes. And more importantly, every feature planned by the business, we cannot deliver every feature separately after it has been tested and at D+1. We keep this a day window to have the application run on the testing environment. So we know for sure that it won't be longer than a day. And yes, of course, because of the capability to have each feature deliver separately, we can do 1 deliver per day. So how did we end up having this organization? Well, I first start with the basics. And when we talk about basics, I like to go to the Agile Manifesto, which has changed the industry, the IT industry, especially on the first principle of Agile, which states, as you can read, that the priority when doing Agile is to continuously deliver value to the customer. And in fact, this priority to accelerate and do the things faster and faster, it's a pattern that we have seen in many companies lately. So for most enterprises, they are doing delivery per month, but many companies like Facebook, Etsy, GitHub, Google, and so on, they do at least one delivery per day, but for many of them, they do continuous deployment and they deploy multiple times a day. Among all the things that have changed for this company, one of the most important is that they don't have QA anymore. This was your question. They do automate everything. They build their tools. They build tools to do this. And they just let programmers, developers, do the QA themselves, often in pair with the business. Still on the basic, when talking about continuous delivery, I like to talk about this book, Continuous Delivery. So, who has already read this book? I'm interested. Okay, this is definitely a must-read book when you want to do continuous delivery. There are a lot of good recipes from the trenches. So, we were already doing many of them, like continuous integration, good testing, both on unit and integration tests. But to improve our continuous delivery pipeline, we decided to focus on 5 points, which are having a build, a faster build, having a reliable build, building each feature separately and knowing when it fails, why it fails, having a simple and automated deployment, and often we call it the one button. Having, of course, because when you deliver a lot your application, if it fails, you want to know it the earliest possible. So it comes with a good monitoring, a good alert system. And because at a point it will fail in production, you have to implement a good root cause analysis process. So these are the 5 points we were focused on. And to improve our delivery pipeline, we did it step by step. And what's interesting is we did it step by step, but we decided to start by the end of the pipeline. And by the end, I mean first improve and fix the things closer to the production. So for us, it means operating the production, monitoring the production, and then going forward, backward, improving how you deploy the application, then how you validate your application, your release. Then, and then only then, we have changed how we develop the application and the development of work. So I'm going to explain all these steps and how we change them. First, on the production, we were already doing technical monitoring the servers, monitoring the disk, monitoring the load of your database, and so on. But the first thing we decided is to have functional monitoring. And for a website like a comparison, an insurance comparison website, what's important is to monitor how good your conversion between people landing on your pages and people leaving your site is performing. And at every time we deploy the application, this is one of the key metrics we look for. We don't want this to course, when you have your key metrics, you have to display it. So one of the important steps, it seems simple, but it was just about 2 TVs for the open space and display this key metrics. So every developer and everybody on the IT team is concerned about these metrics. So that it's, well, sorry about the photo, but it's very simple. It's the target for the month, how well we are performing for the month, the number of bugs currently in production, the number of features currently developed, and there is a special one for the stack, the number of errors currently happening in production. And we know for sure, just by looking at this TV, that there is something good or wrong in the production. Now after the production itself, we decided to improve the deployment pipeline. So we were already using tools like Maven to build the application, Jenkins for continuous integration. But the next step was to use Jenkins and a bunch of scripts to improve and automate how we deploy the application in production. So now everything is automated from stopping the old version to deploy the next version. In fact, it's now so simple that any developer on the team can do it. So how does it work? Well, every day we list the features ready to be deployed in production. We list it in our chat channel, Slack in our case, and there is an election based on the list of who is doing the release of the day. So this is a very simple process, but and the idea is anybody can do it at every day, and importantly, everybody is responsible to do it at one time. In fact, it's now so simple that every new developer coming on the team on his first day do the release in production in pair, but it's like, hey, welcome, you are doing the release today. Now let's focus on the deployment itself. So we use what is called the blue-green deployment, and the idea is to have 2 versions of the application running at the same time. So we have the blue version, the current version. We have prepared it and built the next version. We deploy it on another set of servers, and we redirect the traffic from our load balancer, HA proxy, to the next version. Okay. So during a window of 30 minutes, there are people on the previous version and people on the new version. And at the end, we just know that everybody has been redirected to the next version. And this is simple, just with few scripts, and it works well for us. So usually, people ask me about database. Yeah. How does it work when you want to change your schema? Well, for us, it works because we don't have to change the database. We don't, well, sometimes it happens, but it's so rare that it's not a problem for us. If you want to change your database schema, there are tools for this, and there is a chapter dedicated in the book I mentioned. The idea is to have multiple versions of your application handling the database changes. Now, about the validation. So QA is definitely what change and what we improve. Now the developer have to QA themselves the feature. So each feature is deployed on a Docker container, and the developer do the QA along with a business people. Before, I forgot to mention that before doing the deployment, we go through pair programming and code reviews, and the code is very important for us. We first ensure the quality of the code, and then deploy on the Docker. when the feature is ready to be deployed, we just change its status on Jira and have a ready for production flag. And this is this flag which is automatically used by our scripts to be packaged on the next version. Now the seleniums. Well, this is interesting. So we started with seleniums, 1 hour seleniums, and in fact we didn't change our seleniums. We just decided to use a bigger server. So it was a very pragmatic approach. It cost us 300 euros per month, so $300 if you want. And the main trick was to use Selenium Grid and have everything in one. But it was a 2 days work to win 4 times the time. Yes, and to do the QA, because we are a website, and what's really important for our website is the layout of the pages, we built our own visual regression tool. This tool is named XenoPixel, and it's a very simple tool that goes through a list of URLs in production, takes screenshots, goes through the same list of URLs on pre-production, on the next version going to be released, and do a diff one by one of all the screenshots. And when we find a difference, it shows where the difference is. The tool is open source on the GitHub, so you may want to check this. For now, it's still manual, so even if the tool automatically takes screenshots, it's manual for the developer doing the release to check that everything has changed, but at least it's simpler and faster. We could have automated it, but it will have takes more time, and for this level of automation was enough. Now, what something that changed also, it was our development workflow. So before we were all doing the development on SVM, and now we are on Git. Before we are all doing the development on one branch, and now we have multiple branches, one per feature. There is often a workflow recommended for this kind of development, which is called Git flow. So I don't know who's familiar with Git and Git flow. Who's familiar with the Git flow developing model process? Okay. It's quite popular now. So the idea is you have your version in production, you create a branch from this version, you have multiple feature branch from this next version going to be deployed, and whenever they are ready, you merge it. And when you are happy with this develop branch, this becomes your next branch going in production. The problem with this workflow is that you have multiple feature branches, and you don't know for sure that when you merge them on the develop branch, what will happen. Maybe they will have conflicts, maybe they will have regressions. In fact, there was a guy quoting this. Well, if you are doing feature branches, you're not doing continuous integration anymore. And this is why many people also advocate, and this is what Google and GitHub are doing. They advocate for trunk-based development, where everybody commits on the trunk, or have very short lightning branch and merge them on the trunk as fast as possible, and the trunk, the master in Git, is your stable version going in production. But for us, having the master, the trunk, stable at every time and ready to go in production seemed too difficult. So there was a problem. We wanted to to have feature branches and continuous integration of these feature branches. So we came with a simple idea. Let's do both. And it seemed crazy. But we built a tool which is called Octopus. Again, it's open source on their GitHub repository. It's Octopus. So it's a simple script that every time that will merge every time there is a commit on a feature branch. So here I have the master, which is my production, my current production. I have two feature branches, and the script on the continuous integration server will merge all of them. And if everything merges without conflicts, it will deploy the version. It will pass the test on the version, the unit test, and it will run also the Selenium test, and it will let everybody play and QA on an environment. And every time there is a new commit on any branch, well, we'll simply delete the previous commit, the Octopus commit, and build it again. So this is how we are doing continuous integration of feature branches. Whenever the feature is ready to go in production, well, we simply merge it on the master and deploy this in production and delete the branch. Let me show you a quick demo of this one. Is it okay or too dark?
It's fine.
It's fine? Okay. So because I don't work for this company anymore, I couldn't reuse their code base. So I decided to use a popular repo which is called Linux. So locally, I'm working on a branch which is my features 2, 5, 6. Okay. And on the remote repository, the one from Mr. Torvald, there are many pull requests that I will list. Okay. And let's assume these pull requests are also these pull requests are kind of features in development also. So all this list is a few pull requests from the Linux repository. Okay. So the goal of the tool script is to make sure my current feature branch will merge with all these other feature branches. So I will just have to run my script. Okay, so now it's trying to merge my branch with all the others. This current branch, I know for sure there is a conflict. Someone has done a change on this branch at the same place of the file I'm changing myself. So it shows the conflict. And then it's trying to merge with all the other branches. And it's working fine with all the others. But at the end, it will just tells me, well, your work will not merge with this feature. At that time, you have multiple solutions to fix it. Either one of you, well, don't change this for now, or you avoid conflicts, or you rebase on the other branch. Now let's see what happens when everything is working fine. So I will switch to my other feature branch. Okay, I've now switched to my other features currently in development. And for this one, I will also run the script, but with an option to keep the commit. the merge commit, I was looking for this octopus commit. So it's -c object like commit. Okay, so now it's working well. My branch in development can merge with all the other branches. It's a success. So this is source to it, a guide for Git. And what I wanted to show you is it has created this new commit. And we can see there is many ancestors of this commit, and each of them is a feature branch. So this is what happens every time we push a commit on the remote repository. And this commit is then built, packaged, and deployed on our testing environment. All right. So it seemed a crazy idea at the beginning, trying to merge all of these features, all of these branches together. But it happened, it worked well. And in fact, we have 30 or 40 branches in parallel, and all of them are merging well. Sometimes it doesn't merge well, but we always found a solution.
My question.
Yes.
So, like, what is the objective of doing all those merges? Just to make sure that the code's compatible with each other, or because you're not going to actually use that?
No,
that
we are
merge
not
code.
deploying this code in production because we want to know that it's mergeable
Okay.
all together, and we want to know it as soon as possible.
Okay.
We don't want to wait that
So
the feature is ready to try to merge it with the others.
So if there's a conflict, you're catching it as soon as you can.
Yes, exactly. The idea is very fast.
Even if the branches are, somebody's in the process of working on it,
Yes.
they're not finished yet.
Yes.
Okay.
Yeah, because if somebody is working on a code that somebody else is working on another team, we want to know it as soon as possible.
Okay.
And we use Slack a lot, and we know for sure that every time this build is failing, the build merging all the branches, there is somebody saying, hey, this is not merging anymore. Who has sent a wrong commit? And you know for sure that in the 5 minutes, either the conflict is solved or the branch is removed from the repository.
Wow.
But yes, you're right. The idea is to fail fast and to know as soon as possible that if something is not merging with the other.
Are you running unit tests as you're doing this too?
Yes.
Okay.
We are also running tests on this.
Okay.
Unit test and Selenium.
Every commit triggers unit test, or
Yes. Every commit
in the feature branch.
in the feature branch triggers your unit test. This is why it's important to have a screaming unit build also. So every commit, every feature branch is first test alone, and then the octopus commit is tested as well.
So it's all scripted to trigger one after another, or you do manually?
It's well, for this side of the continuous integration, we use TeamCity, and it's very simple to trigger this. It's a combination of trigger from the repository and some scripts.
So, and then you want to create a feature branch, you always create from the master, even though it's been like some feature has been merged to that master branch.
Yes, we always create from the master, because the master is always the production. So we always start from the master. And some features, important features have been merged in the master. Many of the developers rebase their features, their branch at the top of the master. I don't know if everybody is familiar with rebase, but It's a Git command to change your starting point of the branch.
So the merge to the Octopus branch, that is automatic, and so there's no pull request.
Yes, the merge. Yes, the merge is automatic. It's triggered by any push in the remote repository.
Do you run into issues with not being able to keep up with the commits? I mean, like, if it's always building and testing, can it keep up with the number of requests that are being submitted?
Sorry.
Like every time somebody checks in
Yes.
their code, or commits their code, you're running this process. So
Yes.
is there any problem with it not being able to keep up with the number of
No.
commits?
No.
Okay. Because you said it takes 15 minutes to run a Selenium, right? So.
Yes, but well, there is a queue
Okay.
on the feature payloads, and we know, well, if there is already a build waiting to be deployed, then the new Octopus commit won't be deployed.
Okay.
It will wait that the first one has been finished to deploy. So if there is a new Octopus commit, it will be the new one. Okay. Any other questions? Yes.
Yeah, so do you use like feature toggles or something to kind of
Good transition for my next slide. Yeah, feature toggle for those who are not familiar with is it's more for trunk-based deployments, like for companies doing trunk-based deployments. Often they don't have a feature finished, but they want it to be as soon as possible on the trunk. So they use feature toggle to disable their features. And well, because we use the feature branches to know which feature is going or not in production, we don't have feature toggle. We have few, but it's a very, very rare case. I would say it's more for A/B testing than for feature toggle. Yes?
If you're not using real-time feature toggles, do you keep the previous version deployed hot so you can roll it back quickly if you need to?
Yes. We keep it on the master. It's just a tag on the master. Well, we both, of course, we keep the package, the build package, the WAR from the previous version. But at any time, we could also build it again on a tag on the master. So every new version deployed in production has also a tag on the master.
So that's a new deployment to get back, to move back.
Yes, yes. It's a new deployment, and the rollback procedure is itself automated. Good advice about it. Even if you automate your rollback procedure, test it, because the first time you use it, it will fail.
So how frequently does this website get rolled back?
A rollback, how frequently? I've seen it less than once a year. Because when you have the ability to deploy faster, at some point you may want to deploy a new version than to roll back to the previous version if you want to do a quick fix. So I've seen many quick deployments, I would say 10 times a year, but just once, maybe not even once a year rollback. But again, this is because you have the ability to deploy your application faster. Yeah, I was on the implementation level, so we don't have many features again. What's interesting, and again because we have the ability to deploy faster, is we have we can hardcode more things. And by things, I mean behavior configuration or things you would have previously used, or which you would have used configuration table on the database or a parameter table. For example, I remember we used discount on insurance, discount from a day to one day to another day, and instead of having this set up on a database, we just hardcode it on the code, on plain in Java and because we know we can change it every day if necessary. So it's more easier to read and to go through the code. All of this, of course, requires a good code base. We know we can merge all of these branches because when we add a new feature, when we change something on the code, it doesn't affect the whole code base. So again, it's important to have an healthy code base.
How do you handle database changes?
Sorry?
How do you handle database changes?
The database changes, we don't have many. Again, it's very rare that it's a database, a schema change. It's more like adding a new row on the database. And when we add things, it's often adding a column or adding a new table. For the rare case, we use FlyWebDB, which is a tool to keep a trace of all your changes in a database. But again, this is very rare in our case. I know there are companies that change their schema a lot, and in this case, you will have to use multiple incremental versions of your application that can both read and write at the same time from one schema to the other. I don't want to go in detail because I don't master this topic, but there is a chapter on the book about that. So these were the steps we took, and now I want to explain what changed for the developers and for the business point of view. For the developers, of course, they have more responsibilities. Okay. They don't do only coding, they also have to test the feature, but they also have to deploy their feature in production. And after the deployment, they will have to look at the value of the feature. So they are more, they know more about the features. They don't fear to do the release in production every day. When before it was an ops doing the release, now every developer can do it. This is what I said at the beginning. The newcomer can even do it. And this follows the simple idea of if it hurts, then do it often. If deploying in your production is painful, just do it often. And at one time it will be so painful that everybody will be committed to improve the process. In fact, many developers worked on the script. It wasn't at all an ops fit. I worked on the script and not ops at all. And it was a developer who built the GitHub topics and so on. Every developers were committed to improve the deployment process because everybody knew that at some time he will have to use it. Yes, we have a better code base, and by better code base, I mean we don't hesitate to throw code away. Because before, throwing code meant throwing a sprint full of feature. Now we just, if we know that a feature is not performing well in production, then the next iteration of this feature, we won't hesitate to just throw the code away. And this is why we get the same number of lines of code in the past years. Okay. And now what changed for the business point of view? Well, what's interesting is, of course, the team grew. Where before there were only 12 developers, now there are 25. The business don't manage anymore the teams, but projects. They use, they plan the features, and they just push the features to any of the available teams. Of course, the features are shorter and like faster in production. And we have now achieved the main goal, which was to have a faster time to market. Thank you. Do we have time for questions?
Actually, we'll have some time at the end.
Okay.
So
And then you're
and then there's a little more food up here. Jimmy goes till 8 o'clock, so somewhere around there. We actually have the room until 8:30. Around 8:30, the library will start getting a little nervous, and Nancy will start encouraging us to back up. Library actually closes until 9.
Talking about food, there is something I often do in France is going on the companies to present the talk for food during the lunch. So I'd be happy to talk at any of your company if you want to have this topic for others. All right. Thank you.